cease the talking. Get out your homework. Let's go. Hey, over there, that corner, get your stuff out. Let's go. You guys are doing more talking than getting stuff out. You're supposed to be up here, Tristan.
Stupid name. I was gonna learn, bro. Yeah, he's called me stupid. I used to. I didn't call you stupid. I didn't call you stupid. I said
let's not call each other stupid.
Yeah. What did you hear?
All right, Rylan. Nathan, stop, please. All right. Now, I will just say this on the homework. We did more. Just sit. It'll be fine. We did more challenging ones in class than actually were on homework. Right? Some of the ones on homework were pretty simple. Now, I could get up to around 19 or so. Those were like the ones that we did in class. So, but we did far more of the challenging ones in class. Any questions on the homework? All right, let's grade this. Get your papers out. Let's go. Number 1 is 2/3, fully reduced. Number 2 is 3/4. Number 3 is 1/100 or 1/10 squared. I'll accept either one. Number 4 is 100. Hey, guys, please stop. Number 5 is just the number 4. Number 6 is just the number 2. Number 7 is 200. Number 8 is 3/10. Wait. Yeah, that's the right. Number 9 is x to the 4th over 2. Number 10 is n to the 4th over 5. Number 11 is 3y squared over x. Number 12 is r over 3s. Number 13 is negative 3xy over 4. Number 14 is 2q over 5. Number 15 is 4cd over 3b. Number 16 is negative 7yz over 8x. Number 17 is z squared over x squared. Number 18 is s to the 3rd over t squared, or s cubed over t squared. 19, 8ac squared, a is to the first power, c is to the second, over 5. And the last one, number 20, is 3xyz pd cubed. No, 3xyz over 4.
Why'd you say pd cubed?
You've never heard that before? Apparently this was a saying in my generation. So when someone had their zipper undone, you would say XYZ PDQ. Examine your zipper pretty darn quick. You never heard that? Okay.
I have. My parents say it too.
Well, yeah, that's kind of what. All right. Ari, grab the pin that says Algebra 1, and today's going to be a little bit more challenging. Okay.
Here.
All right, everyone, go ahead and copy down your homework. Let's see. We don't have a quiz or a test. Friday's career day. You don't need to bring anything except your lunch, obviously, on career day. If you want to bring your books or whatever, student advisement will be taken up to do career day stuff. 5th period, we're going to do an activity. It's going to be 10th graders against 9th graders and probably like volleyball or something like that.
How have I not heard about that?
Because you paid no attention yesterday. Here is your homework. Copy down, please.
No, it's word problems.
No, it's not word problems.
Then why is it so short?
Because you only need to do a few of these. These are not word problems. I'm pretty certain these are just the more challenging ones. Remember I said they'll get hard until around 19 or 20. Now they get harder. All right, today we're going to basically combine everything that we've done so far with exponents. So other than adding, subtracting, we're not going to do adding, subtracting. Okay, but we are going to do power to a power, we are going to do multiply rule, we are going to use the division rules. We're going to use everything that we've learned so far. These get messy. They're not impossible. They're somewhat easy, but they do have a slight bit of complexity to them. It's not just one step type thing. So here we go. Remember, this section is still called Dividing Mononomials. I just didn't want to give you one day and we jumped to the really challenging one. So we've had, a nice easy day. We'll have a second easy day. Let's do a quick review of power to a power. Rylan, what's the answer?
The answer is B12.
B to the 12th power. Remember, when you have a power raised to another power, we multiply the exponents. We write this, and then we multiply the exponents. So that's the rule. It's called the power to the power rule. Some people call it the multiply rule, but technically it's the power of the power rule. Okay? So the rule in general is if you have any base raised to a power, and then the whole thing is raised to another power, you rewrite the base. In other words, rewrite A and do M times N, and that's your answer. Okay? Yeah. We are going to be doing dividing a whole lot of things.
Are we basically simplifying the fraction?
Yeah, but we're going to be combining this rule and the other rule of multiplication and division, all three in one shot. Okay? All right. So this right here is the one you have to be careful on. Look on the board, please. Notice I got division symbol, fraction R, right? I got power to power, I got a polynomial just sitting there all by itself, right? Okay. You didn't hand out the papers?
No.
Who was?
Ari was that.
Ari, when you grabbed the box, I said grab the box for Algebra 1. Okay. What did you do with the stuff that was in the box, or you just grabbed an empty one? Okay. Okay. So luckily we haven't got to a box yet. So everybody look up here. So we got B to the second power, and the whole thing's raised to the fourth power. So the numerator turns into what? The numerator turns into what?
B to the 8th power.
Okay, and that's all over C to the third power. So it's not the distributive property, but it kind of feels like the distributive property, right? You're applying that 4 through multiplication to the 3. So you have B to the 8th, right, over C to the third. Can you do anything with these two bases, B and C?
No.
Why not? Because they're different, okay? So you are not allowed to do, 8 minus 3, right? The division rule that we learned yesterday. The only time you can do that is when the base is, if there was a B on the bottom. And by the way, there will be eventually a B on the bottom.
So you just leave it alone?
Leave it alone. When the bases are not the same, there's nothing else you can do. Okay? So here is the first new one. You see it?
Oh, yes.
Why is this one new?
I get it. Okay, I got this. Because the parentheses are on the actual fraction.
The parentheses are on the whole darn thing. So in other words, I'm taking this thing on the inside and raising it to the fourth power. So like I said, it has the flavor of the distributive property. Well, clearly I need to apply that 4 to the 2.
So do you apply the 4 to the
But I also have to apply it to the 3 as well, because the whole thing's in parentheses.
Why not B and C?
Okay. Why not what?
Why not B and C? Why don't you?
Well, remember, the rule of power to power is you do nothing with the base, you multiply the exponents.
So it'd be
Okay.
B8.
So this would be B to the
8
over,
C.
and we can't do anything with the B and the C because they're not the same bases.
Oh.
I get what
Okay?
Okay.
So this isn't that hard, but it will get a bit more challenging. This is just like the start. Okay? Piper?
So we're just doing what we
We're doing what we did, except we're doing it both to the numerator and the denominator. Why? Because the whole fraction is inside the parentheses. If the whole fraction is not inside the parentheses, then you only do it to whatever's inside the parentheses. Okay? All right. So that's what it turns into. That's what it turns. Notice the difference. The top one was the first one we did. The parentheses are only around the numerator. On the bottom one, it's around the whole darn fraction. So the top one, the 4 only goes to the 2, it didn't go to the 3. But on the bottom one, since the whole thing's in the parentheses, that 4 goes to every exponent that you see. These are the easy ones. Eventually, there's going to be 3 or 4 things inside the parentheses that you will have to apply the exponent to. So let's look at some of those. All right. This time, one of those exponents is hidden. Which one is hiding? Right. 5 is actually to what power? To the first power. So don't think that that 3 only goes to the 4. It goes to the first power as well too. Sometimes it helps to write the 1. It's up to you. Most kids can do this and just simply write the answer. The answer is
Z12
to the
ones.
to the third power. Why the third power? Because it's 1 times 3.
Yeah.
That 3 has to go to the first power. We are just lazy. We just don't write the 1 right here. Okay, but it's still 1 times 3. Now the book will not write 5 to the third. They will actually do 5 times 5 times 5, which is 125. I'm okay, unless it's something really easy, like 2 to the second or 2 to the third power. You need to write what that is. I'll just say 5 to the third is pretty easy as well, too. 5 to the 15th, you're not doing that. That's way too big of a number. Okay? All right, so that's the answer that would be in the book. I would not mark this wrong, though. All right, here's a more challenging one. Okay? Everyone stop what you're doing and look at the board. Rowan, tell me what to do. Okay, what do you get? Why is this one different than the previous ones? Look, we got the same basis now, x, so we can use what we did last night. Haley, what did we do last night when the bases were the same and there was a fraction bar? What did you do last night to get to a final answer? You had a fraction bar. Okay, we did this canceling thing. We said 12 on the top, 6 on the bottom. That would leave us with what? If you had 12 on the top and 6 on the bottom, that would leave us with 2 ways of thinking about it. You can think of the canceling, or you can think of it as subtraction. Which one you want? Canceling, 12 on the top, 6 on the bottom. Cancel, what will you be left with? How about 6? It's not 12 divided by 6. It's 12 minus 6. Yesterday's class, when the bases are the same and there's a division symbol, you rewrite the base and you subtract the exponents. Last class, right? 12 minus 6 is 6. Or the other way of thinking about it, most kids don't actually do this. They simply say, hey, 12 on the top, 6 on the bottom, cancel, 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 6 times. You're left with 6 on the top. Okay? Oh, by the way, who's the smarty pants in here can tell me a different way of doing this? Not easier, it's just different. There's the start. Is there a different way of doing this?
Well, just times 2 by the top number.
Okay. Yeah, well, that'll give you 12, not 6.
Oh, all right.
And it's a coincidence the bottom is 3. Randy, you got something? Anna, you got anything? All right, look up here. Just look what's inside the parentheses. We got an x and an x. Couldn't you reduce it first? It's like you had 10 over 20 inside. You could reduce it first. So what's x over 6 and x over third reduced?
6 divided by 3, which is 2.
Yeah, but it's not division. It's subtraction.
4.
So 6 minus 3 is
3.
So, or you can think of a 6 on the top, 3 on the bottom, cancel, cancel, cancel. You're left with 3. So you'd be left with that. And then you could apply the rule and get the same answer. Here's 2 different ways of doing the same problem. If you want to make a case for why which one is the same number of steps, but if you want to make a case of why the bottom one is slightly better, when you multiply by this number, you get what? Really big numbers, or you could. This was 21, you're going to get really big numbers. If you reduce what's inside the fraction or inside the parentheses first, hey, I reduced it, then the math is slightly easier. Here's 2 ways of doing the same problem. Pick whichever one floats your boat. Me, I'm going to use the bottom one. I'm going to reduce first because it makes the numbers smaller than I have to multiply. Well, you just multiply what you agreed, but if this was 21, that wouldn't be the case. Tonight for homework, it could be a 21. All right, once again, I'll show you both ways. The first way is we distribute this 2 to everything. Go ahead, Tristan. Tell me what the answer is.
No, that's x to the 10th.
Over.
X to the 4th.
So doing it the way, it's not called the distributive property, but doing power of a power rule, we get x to the 10th over x to the 4th. We okay? We got 10 on the top, 4 on the bottom. After you cancel, you'd be left with x to the 6th, right? 10 minus 4 is 6, right? The other way of looking at it is if the bases are the same inside the parentheses, reduced from the start. 5 minus 2 is
3.
So this is x to the 3rd to the 2nd power, which is, come on,
6.
it's the same answer.
So
I mean, if you're going to make an argument, the bottom one is slightly easier because the numbers are smaller. You're like, well, that's not that hard. If it's 10, if I agreed. But when the numbers are larger, maybe it makes sense to reduce it first. Okay? I'll allow you to pick whichever one you like. Who's confused? Can everyone see there's 2 different ways of doing this? Yet you still get to the same answer. Most people probably, once you do a bunch of these, choose the second method. It's easier because the numbers stay smaller. Okay, there's 4 problems in front of you. 2 of them, hint, 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 are inside parentheses. 2 of them are not. They're not all done the same way. All right, do box number 1, please. What? Sometimes there's not 22. Where's that a 1? Can't read what's down here, but so far it looks okay. Okay. Looks like scribble. Are you good?
Would this one be either?
Yes, absolutely. And you did it the second one, not the first one.
Yeah.
Julie? So these would be the 2 different types. One where the parentheses encompasses the entire fraction, and one where the parentheses only either do the numerator or the denominator. It could be either one. I've only put in the numerator so far. So that's how the 2 look. Now, what's your question? First one or second one? First one, I'm taking this 4 and multiplying by 2. This 3 is not raised to the 4th power. But on the second one, both of these are raised to the 2nd power. So on the second one, both of them get multiplied by 2. Yeah. Well, we're about to go over the answer because everyone's looking at me right now. Mike, first one, what do you got? Yeah, that 4 only applies to the 2 on the inside. It doesn't apply to the 3. You okay?
Oh, okay.
All right. Porter, you got the bottom one? All right, what do you think you need to do? Okay, so you want to multiply first or do you want to reduce first? Your choice. Let's reduce. 7 on the top, 5 on the bottom. That would leave you with 2. A to the 2nd power. A to the 2nd to the 2nd would give you a to the 4th, and you're done. If you don't choose that method, then you're applying this 2 to both the numerator and the denominator's exponent. 2 times 7 is 14. 2 times 5 is 10. I'm doing it the first way. 14 on the top, 10 on the bottom. Cancel, cancel, cancel a bunch of times. You'll be left with 4 on the top. It's really up to you which method you use. Porter chose, Tristan did the same thing. He chose the second method. Reduce it first. 7 minus 5 is 2. 2 times 2 is 4. Second method is just a little bit smaller numbers to deal with. All right, Julie, you want to try this one? What do you get? Don't overthink it, just do it. 10 to the, because 3 times 3 is 21. It's 9, right? Remember, the 3 on the outside will go to every exponent on the inside. As long as, Julie, it looks like this and not like that. When it looks like this, then the 4 only goes to everything on this parenthesis. So basically, the outside exponent goes to every exponent on the inside of the parentheses. All right, what do you got, Aiden? Last one?
X going to the 12 and
X what?
to the 12.
Over.
Over.
Remember, the 4 has to go to every power on the inside. You got that one. That's the 12. But it also goes to this one.
X2.
Yeah, X is to what power right now?
First.
So 4 times 1 is
4.
So the final answer is x to the
X to the 12 still.
x to the
4.
y to the
Third.
No.
Huh?
Do you want
Four-
this?
X to the 4th. Oh, yeah.
right. So what is it?
X to the 4th and Z to the 4th. Or Y to the 4th.
Y to the
Third. Oh, 12.
to the 12 all over.
To 12.
Notice parentheses go around the whole thing. The power goes to everything. Parentheses around just the top or the bottom, then it just goes to just the top.
Just the print.
Correct. So that's what you get.
I didn't know you do X.
Why is there an X on the bottom? +1 for Rowan. Thank you. I've used that slide now for 3 years. And no one's caught except for Rowan.
Why can't
What? Well, I wrote X. It's supposed to be Z. All right. Rowan's making me look better for next year. All right. Thank you, Rowan. All right. More complicated ones.
I cake surgery. Why do you eat such a tiny piece and then try to water it down?
But what was the point?
What is the purpose?
Wow, that's true.
It's butter. Oh.
That's just wasting the butter.
How long do you think this took?
Hold on, I got this.
Okay.
You just let him break his.
He's like trying so hard to stay okay.
Imagine the mishaps.
Imagine that messing up and just hurting you.
He's so upset.
All for that.
I guess that's one way to get a piece of cake, but
Well, breaking your
most
computer.
complicated, right? That's the most complicated way of
Did that? All that junk
Chucky's
cake.
so weird.
Grab it. I just
All right.
like
His laptop broke.
Okay, so the only difference between ones we're about to listen, please. The only ones that we're going to do differently is there's going to be more than one thing on the inside, and there's going to be things that you can cancel at the end. Okay, so let's see. Parentheses, not around the whole thing, but just the top, so the 4 goes to everything on the inside. Okay, so 2 is to what power? What to start with? 1. R is to what power to start with? To start with, it's to the first power. Once you distribute, it's not really distributing. Once you distribute this 4 to the inside, you're left with? Okay, 2 to the 4th, R to the 4th.
So
Now that looks a whole lot like this, right? Just be careful. Take your time, look at it. All right, what I do is I'm going to go from left to right, and we're going to deal with one piece of the fraction at a time. So 2 to the 4th and 2. What are you left with? 2 to the
Third.
2 to the 3rd. Now, if you want to think about it as 4 on the top, 1 on the bottom, you'd be left with 3 on the top. That's fine. Or you could think of 4 minus 1. It's 2 to the 3rd. That one's done. What about r to the 4th over r to the 4th?
R.
It cancels. It just turns into not r, turns into 1. Anything divided by itself is 1. So you told me we were left with 2 to the what?
Third.
2 to the 3rd power. So 4 minus 1, if you want to do it that way, 2 to the 3rd. But the back of the book will claim the answer is
8. Hold on, keep it
not
up.
6, but
8.
8. Okay?
Hold on.
2 times 2 times 2 is 8. Okay? They're going to get more complicated. They're going to have 3 things. I don't think they get more than 3. Okay? Algebra is not hard. The hard thing about algebra, paradoxically, the hard thing about algebra is just sitting in class and paying attention and doing examples and doing your homework. The problem is every single day it's new stuff. You didn't know about this yesterday, now you do. Okay? All right, so I got 2 things on the inside. Once again, notice the powers only go to the parentheses. The parentheses don't go around the whole parenthesis. It looks like almost the same thing, but it's slightly different. So top, and then we'll do the bottom. 3 to the t to the
6.
okay. On the bottom, you get 3 to the and t to the 6. Okay. I don't want to go too fast. Stop me if you're
Wait,
not
how do
following.
we get 6 on the bottom?
2 times 3 is 6.
Oh.
Clearly, the t to the 6 is canceled. So all we're really looking at is that. So what are you left with?
3.
Just plain old 3 on the top, right?
Oh.
T to the 6 cancel, and you're left with 3.
That's
Is everybody okay? All right, it's not that hard, right? If you had not done that, if you learned to expand it, 3 to the 3rd is 27, 3 squared is 9, 27 divided by 9 is 3. I would not do that. I would, use the rule for exponents. Just makes your life a little bit easier. All right, this is box what, 4?
Yeah.
All right, box 4, here we go. One thing at a time, we'll do the top, then we'll do the bottom. This 2 has to go to every exponent on the inside. So that's
2
2
to the
to
second
the
power.
A to the
Second power.
then B to the.
Second power.
That's not that bad. It really kind of looks like the bottom, but it's slight changes. One piece at a time. There's 3 things we got to deal with now.
So it just be
2 to the
regular
second
2,
over 2 would be left
2,
with.
1.
Remember yesterday I said sometimes it's easier just to draw a long fraction bar when you have things that wind up top and bottom. I'll draw the long fraction bar first,
So
and I'll just put things where they need to go. 2 on the top, 1 on the bottom. You're left with
2.
on the top or bottom. Okay, so what I'm doing. You got 2 on the top, 1 on the bottom. You'd be left with 1 on the top. B squared over B squared.
Canceled out.
Well, I'm left with nothing on the bottom. Remember, you're never left with nothing because this red line actually means 1. So I'm left with 1 on the bottom. But if everything on the top cancels out, you're still left with 1. If everything on the bottom left cancels out, you're still left with 1. Well, clearly 2a divided by 1 is just plain 2a. So the answer is 2a. All that mess over there turns into 2a. Algebra is more about dealing with messes than it is about much of other things. One of the reasons we learn algebra is so that we can do higher level mathematics. And a lot of algebra is about simplifying. We're basically simplifying this. All right, quick reminder, because we're about to do some negatives now. If you need to write this down, write this down. If the negative is on the outside of the parentheses, I don't care what the power is. Your answer is always negative. You can think of this as subtract this. If the negative is on the inside of the parentheses and you have an exponent, some weird things can happen. It turns out if n is an odd number, because you're multiplying things an odd number of times, they don't pair up evenly, then the answer is negative. But if n is a even number, because you'd have a negative times a negative, that would be 2. Then a negative times a negative, that would be another 2. Then a negative times a negative, you've got a bunch of pairs of negatives. Any times a negative is a positive. Negatives on the inside, it could be positive or negative. It just depends whether the exponent is odd or even. Negatives on the outside, the answer is negative. We've seen this one time before. Okay? All right, let's do some with negatives. So once again, I got something here and I got an exponent. I need to apply the exponent to the inside. This would turn into, oh wait, negatives on the inside could be odd or it could be negative or positive. It depends whether that's odd or even. 9 is, so the answer is going to be negative. So we're going to get negative z to the 9th on the top and on the bottom, negative on the inside. But this time I have a even, so it's positive. So I get a negative z 9th on the top and a positive z 6th on the bottom. Yes?
So if you had like, say your final answer was like t to the 12th over like t to the 25th, would it be a
We haven't done one like that yet, but we will, not today though.
Yeah, but what would you do?
You would be left with the things on the bottom. Really, if you follow the rule though, you're left with a
Negative x.
you're left with a negative exponent. We
So
still got
what
to
would
talk
you
about
just
that.
do?
We're just not at that class yet.
What would you do?
That's why I haven't explained it that
But
way
it's on
yet.
the homework.
Agreed, but remember I said draw the long fraction bar and decide whether you're left with things on the top, numerator, or things on the bottom, denominator. We'll talk about the real rule for what happens when you get negative exponents, not today. I don't know if it's next class or the following class. Back to this one. 9 on the top, 6 on the bottom, you would be left with 3 on the top or bottom. Josie's question was this, tonight for homework, if it was negative z to the 6th over z to the 9th, we'd be left with, Josie,
You put like, you'd be
you got 6 on the top, 9 on the bottom, you'd be left with
negative. But what would you put on the top?
1.
Oh, never mind.
Usually there's other things, so that it's not that one, but if everything drops away and there's nothing there, you put a 1. So this would be negative z to the 3rd. Okay? That would be negative z to the 3rd as well, but this one, I'm sorry, this would be 1 over negative z to the 3rd. This one is just negative z to the 3rd. Okay? We okay? All right. This is box number 5. Here we go. Oh, math teacher trying to mess with you. Lots of negatives. All right. 8 is what? Odd or even?
Even.
So just this part gives us what? Positive or negative? That's going to give us a positive, but there's a negative outside, so it's going to be negative. Okay. Math teachers like to do that. That 8, though, has to go to every power on the inside. We already agreed that it's going to be positive on the top, so that's going to be x to the y to the, all right, all over that other stuff. Okay? Why is there still a negative there? Well, this one turns it positive, but that one turns it negative. All right, Josie, 8 on the top, 1 on the bottom, you'd be left with?
You put -1, but you would
Yeah,
put
but
1 over negative x to the, yeah.
for me, I draw the long fraction bar. I put equals long fraction bar, and I just put things where they need to go. If there were 8 x's on the top and 1 on the bottom, you'd be left with?
Negative x to the 7th.
Top or bottom?
The top.
On the top. So I'd write negative x to the 7th. 8 on the top, 9 on the bottom, you'd be left with?
Y.
On the top or bottom?
Bottom.
That's how I do it. Okay? The issue is, and I wish the book would do it in slightly different order, is that if you do 8 minus 9, you get -1, right? Well, I guess you can kind of already see what negative exponents do. They move things. All right. So that's your answer. Yes?
Yes.
All right. That's it. Hey, 15 minutes to get your stuff out. Start working on your homework so I can walk around and give you some help when you get to a challenging one. No, not this. I'll get to it.
Can you turn it up to 8?
You guys walked in here and said it's burning up.
I didn't
It's
say
cold.
that. They did. It's not. It's Super Bowl. Rylan can't sleep in. You're not allowed to sleep.
Because I heard shouting.
That's a Rowan because he was screaming.
Everyone?
Yeah.
This entire week.
Have you made your sleep? I'm not stupid.
Order, you got this?
Mr. C.
Mr. C.
What?
She wants you. Haley.
Haley?
Haley.
Oh, Haley Miller.
What
What's up,
other
Haley?
Haley is there?
Was that all for today's class?
Yeah, that's it. We're just going to do our homework right now, and I'm going to walk around helping people. If you need any assistance, just chat me up or send me an email.
Okay, I will.
Okay, see ya.
Bye.
Bye.